Okay, guys, is everyone back? Okay. Well, the next methodology that we will talk about, and we discussed this a little bit yesterday, is rapid application development, right? So in rapid application development, we want to be able to develop something real fast. Now, when we want to develop something real fast, it would help, right, if we had some components of it ready. Yes or no? So when we have some components of it ready, it means that we have a reusable code, right? We have some tools. If you want to build something real fast, you must have the tools for it, correct? So rapid application development, it has tools, it has a reusable code, and of course, they are not only for development, but for testing purposes as well. Now, rapid application development is very similar to prototyping. Why? If you want to develop something real fast and you're using a reusable code, do you think this item is going to be totally different and unique? Can it be? No. Because if you use this code somewhere else, then it has the same behaviors like something else, right? Correct? So it is not going to be totally unique. However, when does it help to build something real fast? If you are doing a proof of concept, right? If you are trying to see, if you're trying to get some customer feedback, if you are trying to analyze a model. So what happens in that case is, before you go out full-fledgedly and invest $300,000 or $2 billion on this project, you want to see if this concept will even fly, if it will actually work or not, right? So you try to simulate it, and you do something really fast to confirm or to do a proof of concept. Does that make sense? Now, when you do a proof of concept, what are the chances of you getting it right? What are the chances, guys? If you're only doing a proof of concept, think of anything for those of you who love to cook. If you have come up with if you have a recipe in mind or an idea in mind, right? And you want to verify it. Do you want to build it from scratch, invest so much time and energy? No, right? The chances are only 50%. So the chances are that it will be a hit or a miss. If it's a hit, then it's an operational model, something that you can use. If it is a miss, then it is a throwaway model. Meaning to say that you learn from this model what worked, what did not work, and you go into another iteration. Yes, no, maybe. This is called rapid application development. Okay? Now, in order for you to be able to develop or use a reusable code, do you think you can have this software built from scratch? Can you have very detailed requirements? No, because there's no custom code here, right? If there's no custom code, then it can't have very detailed requirements. The requirements must be such that we can reuse the old code, right? So the requirements are frozen too early. They are very vague or they're very high level. And secondly, when you're trying to build something real fast, do you think you will maintain and all the design and development standards? No. However, what are the benefits? So the first iteration of rapid application development is your prototype, right? You figure out from your prototype whether this is an operational model or a throwaway model. Then you figure out if it is a throwaway model, what worked, what did not work, and you go into another round. Now, the difference between prototyping and rapid application development is prototyping is 100%, it is custom code. Here, you are using a reusable code. Clear? So prototyping, when Facebook was created, do you think Mark Zuckerberg, or when Google was created, do you think Larry Page used any kind of pre-existing reusable code? Did they have any tools? No. Right? However, now that we are building Google Plus and whatnot, is it still a custom code? Possibly not, right? We have the tools for it. All right? Everyone clear so far? Guys, there are 5 of you on the call right now. I know Shadab can talk, but how about the others? Is Ryan still there? Okay. Next, we come to rational unified process. Now, rational unified process is the golden methodology. Okay. You can do pretty much any project using rational unified process. However, you have to keep in mind, gold prices are really up, aren't they? So that being said, rational unified process, if you use this methodology, it's going to be very expensive for you. And part of the reason why we don't use rational unified process for all our projects is because it is very expensive to do. That is one of the biggest drawbacks. It is a very big, huge, expensive project. Right? Not many companies have that kind of budget to justify a rational development. Are you clear? So what is rational unified process? Now, if you go back and look at all the methodologies that we've learned so far, what did we learn? We learned about waterfall, right? Waterfall, what was the prime objective of waterfall? Prime objective, Nehal. Success criteria, project success criteria. Project success criteria. What was the project success criteria for a waterfall project? Project must be done on time. No, guys, must be done on time, within budget, and the customer must be happy, right? So what other term did I say? For all this, low technical risk. Buzzword. Remember that? So waterfall, we want to keep our technical risk really low. Spiral, what was the objective of spiral? Customer satisfaction, right? Agile. What was the objective of going agile? Faster, very nice. We want to develop something really fast. Rapid application development. We want to be able to verify, do a proof of concept really fast, right? Now, in all of these methodologies, and of course prototyping, same story. We want to develop something, right? So in all of these methodologies that we've learned, the implied is quality, right? When we're building a software, we always assume that the quality of the software is really high. Yes or no? But for any of the methodologies, is quality a success factor? Not an assumption, but is it a success criteria for that methodology? No, that's right, Neha. None. None of the methodologies focus on the quality of the software. Okay? We are working towards making customers happy, doing faster development, all of it, but not necessarily. Our sole focus is not software development, quality of the software. Now, in 1990, actually around 1980 is when the US government started thinking about the software development processes, right? And they were wanting to build some software for their naval systems and for the Air Force systems, right? Aerospace contractors and all, military and aerospace. And they looked at all the methodologies. Not that they were not using the methodologies, but they realized that they can't implement a software on their naval systems, on their submarines, on their aircraft, on their weapon systems, unless it was of very high quality. And none of the methodologies that they had, that they were using at that time, focused on quality. Correct? Can you imagine? We have a software, right? If you build it using waterfall approach, you are, down the way you realize it is only meeting 60% of your objectives. But because you're using traditional waterfall, you still go ahead with the project, right? You deliver something that is only 60% functional. Would you be safe flying on an aircraft where the software is only 60% functional? Look at all these laser, the nuclear warheads and all, right? We use software to trigger all of it, correct? Nuclear power plants. It's all based on software, isn't it? Can you imagine we have a nuclear power plant or a nuclear weapon, facility, and this is when we're talking about 1970s, 1990s, right? This is when we were actually US and most of the world, USSR, we were actually building nuclear warheads, right? We were working on different submarine technology, software for all these submarines, sonic and whatnot, sonar systems and all, right? Can you imagine if those software, it only meets 60% of the criteria of the project objectives? Would you be safe? Would you want to implement that software? No. So they realized that there was a gap. And because they realized that there was a gap, they reached out to a company called Rational Inc. And they sponsored a research on how to develop a software where the project success criteria, of course you're building a software, but the quality of the software is the prime success criteria. Okay? Are you clear? So the actual, the process began earlier. It is that the RUP methodology has been developing since 1995. The government-sponsored academic research began a little sooner, earlier than that. But based on that research that Rational Inc. did, they proposed a methodology in 1995 called the Rational Unified Process. Is everyone clear? Okay. Rational Inc. was later bought out by IBM. And hence, nowadays, it is referred to as IBM Rational Inc. All right? And same goes, the software is also referred to as IBM Rational, the methodology and all the tools that they built. It was later bought out by IBM. Now, what was the methodology? So, what Rational Inc. proposed was, of course, we must develop the software, right? We must have phases. Software development goes through phases. So, it is a linear and sequential process. However, that is not the only dimension. So, RUP methodology has two dimensions. One is the software development process, right? You must develop the process. And while you are developing the process, you must improve the process so that your quality of the product is also very high. What does that mean? Right? So let me give you an example. Guys, all these examples are for you to understand and retain the concept, okay? So the example is, there was this baker, right, who's been handed down a fantastic recipe for donuts. Now, this through generations. She has this memory learned by heart and is making these donuts. Now, these donuts they're fairly good, right? Of course, it's recipe passed down through the generations and all. So she happens to be going someplace and happens to pass by a carpenter's shop and notices that the carpenter has a design laid out in front of him and he is measuring out some wood. She is very, her curiosity, is vacant. She wants to look. He's building the same kind of table, same kind of chairs all around. It's not as if he's building something different or new. But it seems like he is still measuring out, looking at the design and measuring out the wood. So she watches this carpenter a couple of, minutes and realizes that not only is the carpenter measuring it out, but he's actually doing it 3 times before he actually cuts out the wood. All right? So he has measured out, he's looked at his design and marked his wood. Then he goes through the same process twice before he actually cuts the wood. Who can tell me why is the carpenter doing it thrice before he cuts the wood? Common sense. Yes, Nidhi, you can't reverse it. If that piece of wood, even if it is off by a millimeter, right? If the measurements are off, that table is going to wobble, correct? Yes or no? Would you want to buy a chair or a table that wobbles? No. Once the carpenter cuts that piece of wood cannot be repurposed anywhere else, can it? It's done. He can't go back and do something else with it, right? He can't reverse that process. So what did the baker learn? What did she learn? She went back. She realized that if she wants to improve the quality of her donuts, she must improve the process of making the donuts, right? So what did she do? She got that old recipe out, and then she had lined up all the ingredients in front of her. She measured out every ingredient, right, once. And then when she measured it out a second time, how many of us who have cooked or have done some experiment in the past, how many of us have realized that sometimes when they say 1 tablespoon or 1 teaspoon or 1 cup, our measurements are sometimes off. It's either that we have heaped up that cup or spoon. If you level it, you know that you had some excess, or sometimes when you level it, you realize that you need some more. How many of us have had that realization? Many times, right? Same goes, I'm sure, for guys who don't cook. If you are maintaining your own cars or bikes or whatever it is, same goes with the engine oil, right? Sometimes it doesn't matter whether you have 1 or 2 drops less or more. Many times it does, correct? Now imagine if a pinch of baking soda determines how spongy your cake or donut is going to be. Do you think a pinch of extra baking or of extra flour or whether it is sugar will also make a difference to your recipe? 1 added pinch of salt will make it more saltier than what is required, right? Yes or no? So in order to improve the quality of the product, do you think if I improve the process itself, the quality will go up? Yes. And that is why Rational proposed the 2 dimensions to RUP. That yes, you have to develop the software. But while you are developing the software, there are also certain processes that happen during the software development that you must improve. And how do you improve? By doing some iterations. Okay? So SDLC, there are the 4 phases of SDLC. And within each phase, there are certain tasks that we do that if we improve the quality of those tasks, then the overall outcome of the product also goes up. Does that make sense? So RUP is an iterative approach. Are you clear? Another thing that RUP talks about is that if you want to improve the quality of the software, you should be able to include change, right? Can you imagine if I had a requirement, right? And now I realize that I can improve the quality of my software if I change my requirement a little bit. But if my methodology frowned upon on changes, do you think I would still be able to deliver a high quality product? No. So RUP says that in order to improve the quality of the software, if needed, you should be able to change your requirements. Okay? Anything for the quality of the software. So change is okay so long as it is for the quality of the software, not for anything else. Are you clear? Now, another thing that RUP or Rational suggested was the object-oriented approach. So instead of having our variables, right, the time, the cost variables determine what it is that we can build, what they suggested is, Rational suggested, was that we determine what are the features, right, that this software should have, and then determine how much will it cost us. So the features, the quality of the product depends on the features that it has. Yes or no? Do we not say Apple iPhone or Apple iPad is a higher quality product than the T-Mobile Razr that we had 5-6 years ago? Why? Because it has more features, right? So it is the features of the product that should determine the cost of the product, not the cost determine what features we can include or not include in the product. Does that make sense? And that is why they came up with the object-oriented approach. If you will remember of the object-oriented approach, we said that we will, of course, we will gather requirements and then determine what is the cost, but we also said that we will give very specific instructions to the development team on how to build, how this functionality works. Do you remember that? We will give more details on the functional requirements. We are just not going to say, oh, this should be a smart technology, right? People should be able to make a call. Well, the Razr is also allowing people to make a call. So how is the iPhone different than the Razr? Right? Or don't just expect or assume that the developer has the same vision as you. With tapping on the phone number will place a call, right? So you must provide some more details so that the developer can see your idea and then develop accordingly. Now, how he develops it, as in whether he uses Java or C++ or what technology, is up to him. How he writes that code, up to him. However, he knows your vision. He knows not only what functionality you want to build, but how does this functionality work. Do you remember that part? And how that functionality works is your use cases. Right? Definition, if we were to describe a functionality, how this functionality works is a use case. If I were to explain or give you, sometimes people are more pictorial, right? They do say that a picture is worth 1,000 words. So I can also improve the quality of my requirements by putting in some diagrams for those people who are pictorial. Yes or no? They're very visual persons, people. They want a picture makes more sense to them than going through 2 pages of a document, right? So do you think if I were to give them an alternative way, right, by drawing some models or diagrams and whatnot, that it would help them understand the requirements, it would help them understand the software better, that my quality also goes up? Yes. So RUP is based on, it is an object-oriented approach. Because it is an object-oriented approach, it uses UML and use cases. All right? Now RUP, because you're improving the process per phase, it can be very time-consuming. Yes or no? One time measuring all the ingredients, second time measuring all the ingredients, third time measuring all the ingredients. Do you think that's going to be really cumbersome? Right? Same goes if we are going through the first phase, the planning phase, first round, second round, third round. Then we go into the next phase, first round, second round, third round. Going through the same thing again and again, do you think that would be very time consuming or not? Very tedious? Yes. So what Rashom also proposed was to simplify the process. They also built some tools, rational tools, to help with the SDLC approach and the process improvement approach, right? So that it's not a manual process. You're not doing multiple iterations, all of them manually. Tools to help you automate some parts of the process. And because they built tools, guess what? They were not doing it for free, right? There's always a licensing fee. You download something, there's always a user fee, right? Yes or no? Are all the softwares that you download, are all of them free, or do you sometimes have to pay a subscription or license fee? Right? Even Microsoft, you have to pay for it, right? All the Microsoft products, the suite of Microsoft 2010 or Microsoft, whatever it is. Same goes. So Rational, they have a whole suite of products, and you must purchase that suite. It is a very expensive purchase. Okay? Some of those tools are listed here. The tools that they propose were for everything. It's not just for business analysts. Remember, the tools are for the entire SDLC process, which means that there are tools for project management. There are tools for version control. There are tools for testing. There are tools for drawing diagrams by anybody, the development team, design team, business analysts. There are tools for requirements, requirements management. All right? So this is just a high-level introduction of RUP. Now, how does this methodology work? As I mentioned, there are two phases, two dimensions of this methodology, right? The SDLC and the process improvement. Now, SDLC, what did I say? In order to develop the software, it is an incremental and, look here, iterative approach, right? So let's talk about the incremental. This is what we've learned of so far. Incremental approach, right? One phase leads to the next. Yes or no? It is not linear. Why? Because I've already said that it is iterative. Iterative means it goes in cycles. So if it goes in cycles, can it be linear? No. But it is incremental. So increments, what does that mean? You are in the first phase, goes into the next to the next. As you go through from one phase to the next, is there a time lapse or no? Yes. So the SDLC dimension is called the time dimension because it takes time to develop the software. It goes from one phase to the next, to the next, to the next. All right? And in that dimension, there are 4 phases. Those phases are inception, elaboration, construction, and transition. Now, why are these phases, the names of these phases different? Remember, we are following the object-oriented approach, not the traditional approach, right? And because we are following the object-oriented approach, the phases, the names of the phases are different because the tasks and activities that we do in those phases are also a little different. The sequence is different. Yes, no, maybe. Now let's look at the other dimension. We are doing certain tasks and activities. We are following certain processes, right? Throughout the software development life cycle. Yes or no? It is an iterative approach. So we will do those processes, the entire cycle of processes per phase. And there could be multiple iterations of these processes per phase, right? Correct? And that is the second dimension. It's called the process component. It is also called as the workflow. Dimension, component, workflow, same story, discipline. Are you clear? Now, what are the processes? we are going to be making lots of models. What did we learn? What are models? Who remembers what are models? Diagrams, flowcharts, what else? Prototype, what else? Give me some examples of models. A spreadsheet, Nehal, you're very close, but that's not the exact term. What is a model? Return on investment is a model, isn't it? It is a financial model. Net present value, financial model. It's not a diagram, is it? Gantt chart. It is a model for your resource availability of your project, of your work breakdown structure. Yes, no, maybe. Diagrams to explain the process, diagrams to explain the functionality. Those are models. Diagrams to explain the code, diagrams to explain how you have designed the architecture of the software. All of those are models, right or wrong? Now, if you look at these models, can you say that these models are only built during the inception phase or they are only built during the elaboration phase? No, right? It is not like your waterfall. So we are building different kinds of models throughout the SDLC process. So there are some models that you build in inception. There are some models that you build in elaboration phase, right? There are some models that you build in the design phase. So you have a process, business modeling process that happens throughout each of your phases, correct? Yes, no, maybe. So likewise, requirements. Because we are following the object-oriented approach, we are gathering requirements in the inception phase, correct? Because it is our requirements that will determine our project timeline and project budget. Yes or no? So we have requirement gathering in the inception phase, right? Now, what else did we talk about? When we say requirements gathering, are we just talking requirements gathering, or are we also talking about analysis, documentation, validation? We are, correct? So we are doing the same requirements gathering in the elaboration phase as well, aren't we? Now, because we're trying to develop a quality software, so when we get into construction phase and realize that, wait a minute, we need to tweak our requirement, do you think we are also revising our requirements even though our project is in the construction phase? Yes. So notice all of these processes are happening at each of the phases. None of these processes are limited to any particular phase. Unlike waterfall, in waterfall you only did your planning activities in initiation. You did all your requirements activities in the analysis phase. Here, you are doing all of these processes throughout each of these different phases. Yes, no, maybe. And that is the basic difference between RUP and waterfall. So you have the process components, right, for your software process improvement dimension. And then you have the time component for the SDLC dimension. Are you clear? How does it all work? We have our phases on the x-axis. Everyone remember basic graphs, right? X, Y. So as I do my project, I'm going to go from one phase to the next, and while I go through the phases, I am using up some time, right? 0 hours. By this, it is 900 hours of development. Here it is 1800 hours of development. Construction. Remember, if you're focusing on the quality of the software, will I stop developing when I reach my timeline? Or will I continue development until I get the quality that I'm looking for? I will continue. Hence, the column, construction column, is the widest of all. You can only get so much requirements, right? You can only work on your document so much, but this is the development itself, right? Is what you are focusing on, isn't it? All of this leads to construction, doesn't it? And so this is the widest column of all. Of course, you will take up time here, and then and only then do you go into the next phase, right? So we have our SDLC phases in the x-axis, and then we have all our process components or our discipline workflows on the y-axis, okay? Now in this diagram, if you notice, there are 3 additional workflows. These workflows are not related directly to software development. These are administrative workflows, all right, to manage a project. It is not to develop a software. Hence, the previous slide did not have these, all right? It doesn't mean that it is not there. It is just that it is not a software engineering workflow. Are you clear? So if you are asked about the disciplines or the process components, you must list that we have the engineering workflows and the supporting workflows. List everything. There are 9 of them in all. Now, how does it work? So look at it this way. First and foremost, right, because we're doing object-oriented approach, you will start gathering your business requirements. Based on your business requirements, you will put together your scope. You will put together an initial timeline and a budget. Business model. Yes or no? Based on this requirement, based on your initial scope, you're also talking to your design and development team. They are giving you their requirements. If you have your business requirements, and what did we say? You also talk to your IT manager, right? You must understand what software will you need, if we need any licenses, if we need any resources, if there are any technical requirements, right, related to your business requirements. Yes, no, maybe. So that in how long do they think in order, because if you know your requirements, then they should be able to give you a proper estimate of how long do they think it will take for them to develop it. Yes? So you are getting those time and cost estimates from your design and development team, right? So that you can build your timeline and your budget. Same goes from the testing team. They will also review your requirements document and give you an estimate. Deployment team. You must talk to them. They must be aware that there is a project These are your business requirements, and they will give you a rough estimate. Yes, no, maybe. Are you clear? Now, typically, in rough projects, we only have one iteration in the inception phase. Why? Because we understand that even if we were to go into the elaboration phase, we can still make changes to our timeline, to our budget. It is not frozen in time. We still have the flexibility of changing stuff. And so, is there any need for us, if we don't have any further additional information, to go into another iteration? So, if that's the case, then we don't go into another iteration. However, if the entire project team, right, if your stakeholders, they feel that no, we think we can clarify, we can have some more business models, or I don't think we have all our requirements yet, then you go into another round, another iteration of your inception phase. And you will do all of the activities that I just described all over again. Does that make sense? So, when we go into another iteration, right, or before we actually go into another iteration, we as a project team, as the PMO, must have a process for change management. Anytime we make code changes, right, how will we manage that configuration change? How will we manage, document our code change, right? Have you seen every software that you buy that there's a version number, even for not an antivirus? Yes or no? Right? So how will we manage change? There must be a process for it that must be clarified before you begin the project. And hence you have the configuration and change management process component right here in inception. You must define it early on, right? Where will all the change requests be documented? Where will the configurations, the different versions of the documents, where will they be stored? How will the versioning work? Are you clear? Same goes. Project management. When you are doing a rough project, you know it is an iterative approach. You need to figure out how many iterations do you want to have. Should there be 3 iterations per phase? Are you looking at 6 iterations in construction and 3 iterations in elaboration or inception? What is your strategy for the iteration? How long will each iteration take? Right? What is the communication process? What are the milestones? So there must be, again, project management policies that must be defined early on. Yes, no, maybe. Same goes for the last one, which is environment. When you start building a process, a software, you have to take into consideration the operating software, right, operating system that you have in use. You must take into consideration the technology, the platform. You must take into consideration your design standards, development standards, testing standards. Yes or no? What are the tools that you have in place to be able to evaluate if the tools that you have, will they work? Will you be able to use the same tools for developing this new software, or do you need something different? Does the platform that you are using right now, will that work for the new software as well or not? Remember, it is for the development of a quality software. If it means that we must change our platform, then so be it, right? But somebody must evaluate that up front. so that we can add the cost of that to our project budget and timeline? Yes or no? So we will go through, one iteration of the inception phase. And then we will go through, there will be a meeting, a stakeholder meeting. And the stakeholders will vote on how do they feel about this, the outputs of this iteration. There are some key milestones that we will discuss on our next slide. So after the meeting, as a group, the stakeholders decide whether we are ready to go into the next phase or should we go into another iteration. If everyone is in agreement that no, our work is done, there is no way that we can improve the process any further, right? And all of the processes that we did in the inception phase, that we can't improve any of those anymore, then you go into the next phase, which is elaboration. If you notice here, the key activity is requirements elaboration and design elaboration. What does that mean? We are going to do object-oriented analysis of our requirements. We may have written our business and functional requirements up front, but we will elaborate on our functional requirements and write our use cases. Okay? We will draw UML diagrams, which are models. Our design and development team is going to analyze the requirements, and they will put together a technical design solution, elaborating on our requirements. Remember? Object-oriented design. Based on this, they may have more diagrams, models to draw. Yes or no? Based on our requirements and on the technical design, the development team may have some pre-development work, staging work, setting up the environment, right? They may come up with a detailed design document. Remember, the place where the code is first written before you can actually build it, construct it. Somebody must review that this is the right approach to write this code. Yes, no, maybe. So that document must be written. Based on all of these above, the testing team will write down their test plan. We may also write our UAT test scripts. Yes? Of course, through all of it, deployment team must be kept in the loop. Configuration, now remember, we go through one iteration, right? All the stakeholders meet. They must all vote. Do they feel that the requirements are complete? Do they feel that the requirements cannot be clarified any further? Do they feel that the design is good? Do they feel that the models are fine? Do they feel that that our iteration is complete, right? This phase is complete. If the answer is yes, then we can move on to the next phase. If they feel that, wait a minute, because of this design, our requirements need to be changed, right? Then that change must be documented. We go into another iteration. Yes or no? So we will go into another iteration, document the change, do the version number. We will revise all of our models, the requirements, because of the way the software was designed. Because of this may also have to be revised, updated. Your test plans may also need to be updated. Yes, no, maybe. This is how you incorporate change. So you will go into loops or iterations after iterations until everyone confirms that yes, this is fine. This is what we want. Yes, this will meet our objectives. Yes, this will ensure that the quality of the software is really high. Are you clear? When everyone is in agreement, you go into the construction phase. Prime activity, development. They develop, right? One round iteration, development. Then we test that round. They do the unit test, SQA does their testing. SQA comes back and says, wait a minute, nope, we haven't reached our QA standards yet. What is not working? Does it need to be fixed, or is it the requirements needs to be revised? If it is, if it means that the requirements are fine, the design is fine, it's just the code that needs to be developed, then you go into another iteration of development, right? If you find that the code is right, the requirements are wrong, then again, you still need to go into another iteration. In which case, irrespective of whether it is the code that needs to be changed, then it is more of a configuration. If it is, right? If it is the requirements that need to be changed, again, you must go through the configuration and change management. You must document what changed between iteration 1 and iteration 2. You must go through all of these all over again. Yes, no, maybe. Does that make sense? You will keep going through one loop of iteration into the next until the SQA team feels confident that yes, this software meets the quality standards. Yes, no, maybe. Again, the stakeholders meet and they must discuss whether it makes sense to move into transition. Now, before we move into transition, if the SQA approves it, we start our UAT. Okay? Are you clear? Or the preparations for UAT. We get into the next phase, which is transition. Here, we do the UAT. If we find any bugs, then those are fixed as well. See that small little hill here? Yes or no? So we will have those bugs fixed. Now, if it means that any of our design, now remember, there should not be any design changes. Because if the software has passed testing, it means that the design that was put together is okay. However, you may have to make some final tweaks, right? That's the reason why we have the solid line. Are you clear? Based on the way it was developed, you may have to make some final adjustments to your use cases, to your requirements. Yes or no? You may have to tweak some of your business models. Yes or no? Remember, business model can be anything. It could be your project plan, net present value, anything, right? You are in transition. What is the other activity that happens in the last phase of the project? Training and deployment, right? That's something else that we are working on. So deployment activities, training, deployment. Think of this. This is a software that is being built for the naval system, submarines. Do you think we can install this software on all 3,000 or 6,000 submarines that the U.S. Army, the U.S. Navy has, all in one go? Can we train all the operators all in one go? So we will go through iterations of training, iterations of deployment, right? Training and retraining until they know exactly how to use it. Yes, no, maybe. If I give you, how many of you know all the features of your iPhone or smartphone or your laptop? 100% of all the features. If you don't know all the features, the reason why I built this software with these 10 features is so that it can meet the objectives. If you don't know how to use them, does it meet my objectives? No. So I'm going to go through iteration after iteration of training and transition until everyone is confident. Everyone agrees that yes, all deployment activities have been confirmed. Yes, our requirements are finalized. There are no more changes. Everything is good. The documentation is good. Our models are all perfect. No more changes required there. Right? Development is all complete. No more development required there. Yes or no? Testing is all complete. No more testing required. When that happens, then I close out my project. Otherwise, if the answer is no, wait a minute, we still have one more round of training to do, then that's another iteration for you. Are you clear? Okay. So this is how the RUP model works. Does that make sense? So there's more to be learned on RUP. Remember, this is the golden methodology, right? However, this is where we will stop today. I know you've learned some big ones, big methodologies today. It is going to be confusing, and luckily we have the entire week. Please play back the recording and go through the slides and the information on the blog. A couple of times at least. You must remember everything that has been taught in today's class when we meet on Saturday next. Are you clear? Now, ideally, had we done some more yesterday, then we could have finished our slides today, but I'd rather not rush. This is very critical. I'd rather take my time. We can rush through something else, but not this. Again, remember guys, waterfall, agile, scrum, and RUP. These three are very, very critical. Of course, when I say waterfall, I also mean spiral, all right? This is just an extension. So these you should know like the back of your hand. Okay? All right. I will talk to you all next Saturday, guys. Please don't be late and come prepared. You're all very welcome. Take care.